Alright folks, today we're working on 10.2.8, which is Arithmetic Series, which we'll talk about what a series is in just a second when we go through this problem. Okay, so James is preparing to run a 5K. He runs 0.5 kilometers, 0.75 kilometers, and 1.0 kilometers on his first, second, and third days of training. He continues this pattern. So it says that he's going to do the same thing at this pattern. So at what training day will he reach his goal of running a 5K? So for those of you guys who are not runners, a 5K just says that his distance, right, for his run is 5 kilometers. That's all that says. We're using metric right here. So we know we have a pattern. 0.5 for the first one, 0.75 for the second one, and 1.0 for the last one. So let's check to see if this is arithmetic or geometric. So we know that it looks like we're adding 0.25 every single time. So 0.5 plus 0.25 gives us 0.75, and 0.75 plus 0.25 gives us 1.0. So we can say that we get 1.25 for the next one, and 1.5 for the next one, and 1.75 for the next one, and 2.0 for the next one, and so on and so forth. But this is already, let's see, 1, 2, 3, 4, 5, 6, 7 terms, and we are nowhere near our 5 mark yet, since we're looking to get to a 5 distance. So our terms are not anywhere near, or sorry, this is n on top, anywhere near 5 of them. So looks like the number of terms we have up to 7 is just 2.0. Our 7th term is just 2.0. So maybe let's use our arithmetic, since we've established that we add 0.25 every single time, and our difference is 0.25 and another 0.25 every single time. Let's use our arithmetic sequence formula to figure out our total distance. So our formula from our formula sheet, a sub n equals, let's see, a sub 1 plus n minus 1 times d. So we need to have our common difference, which we know that is 0.25. We don't know the number of terms it is. We're trying to find that. We know that a sub 1 is equal to 0.5. And we know our final distance, what our last term needs to be, is 5 kilometers, or just 5. So we're going to subtract 0.5 on both sides of this one first. So we're going to get, do this work over here, 4.5 equals n minus 1 times 0.25. So before I try to get this, I could distribute this if I wanted to. I think it's going to make more work for myself. I'm just going to divide both sides by 0.25. As this is 0.25 times this stuff, I can divide to get rid of it. So we're going to get 4.5 divided by 0.25 is going to give us 18 equals, let's see, n minus 1. And then we add 1 to both sides. So it says that the n equals 19. So that says at his 19th training day, he will run 5 kilometers. Okay, so this is something we've already been doing this little bit of review. It's just we just wondered, hey, when are we going to get, so 19 days gives us 5.0. When are we going to get 5.0 for our final run? Okay, so write an explicit formula for this series. And here's the key thing to pay attention to. Sum
of a sequence. That's all a series is. So if you have a bunch of them, you just add them together. So let's go to our formula sheet. If you look at your formula sheet, it's going to show you this thing. It's going to for an arithmetic series, and it's going to say this exact thing. It's going to say arithmetic series is given by s of n equals n over 2 times a sub 1 plus a sub n. And we've seen some of these things before. We've seen n. We know what this means. This is the nth term, or the n. It's like the number of terms. So an nth, it's like number of terms. We know this a sub 1 is just the first term. We know this a sub n is the last term. And this s of n just stands for the sum of the series of n terms. So let's plug in everything we know so far. So we don't know what the sum is. So we're just going to say s of n equals. We don't know how many terms we have, n over 2. And then a sub 1, though, isn't going to change. It always means 0.5 for this sequence in the series. And we don't know what our last term number is. So this formula
is going to let us add up all the numbers really quick. It's going to let us, because sum just by the way means add. So if we use this formula, we can just add them up really fast and get a total number without having to add every single individual term. And here's why this is important. So if we use the formula from part B, which is our formula, and the total number of training days from part A, find the total distance that James ran to prepare for his 5K. So we could say, hey, look, let's add all these up individually. So you could say 0.5 plus 0.75 plus 1 plus 1.25 plus 1.5. Uh-oh, made a mistake already. Had to go back and fix it. Plus 1.75 plus 2.0 plus 2.25. But that tedious process, you're bound to make some mistakes in there. So instead, we're going to use our formula. We know that n for this particular one we're looking for is 19 because it's looking for the total distance that he ran to prepare for his 5K. At the 19th training day, he ran 5 kilometers. So we're going to say S sub 19 equals, if we know this n, we know this n as well, is 19 over 2 times 0.5 plus a sub 19. And remember, a sub 19 is just the 19th term. So we could either use that formula to figure this out at some point, but we already know this. We're just going to use it as fact that it's 5.0. So we're going to say S sub 19 equals 19 over 2 times 0.5 plus 5.0, because this is the 19th term. Okay, and then we just type this into a calculator, we get our answer. So let's see here. So 19 over 2 times 0.5 plus 5. 52.25. And you could go through. You're welcome to. I'm not going to because I don't want to spend the time on it. That says he ran 52.5 kilometers. So James ran 52.25 kilometers to prepare for his 5K. That is quite a distance to prepare. But that's how it works. If you run just a little bit more every single day, pretty soon you're running a whole lot of distance. Okay, so let's look at the last one, part D. If James wanted to continue his training for 30 days, what total distance would he have run? So it looks like n equals 30. Our a sub 1 hasn't changed. It's still 0.5. What we don't know is a sub 30, but we can figure that out by using our original formula for our sequence, for an arithmetic sequence. So a sub 30 equals 0.5 plus 30 minus 1 times our common difference of 0.25. So let's see, that's going to give us 0.5 plus, we'll see, 30 minus 1 is 29, so 29 times 0.25. That says on that last day for that a sub 30, he's going to run 7.75 kilometers continuously. 7.75 kilometers. Kilometers for both these. So, let's use our formula. So, S sub 30 equals, let's see, 30 over 2, and I'm just using this formula from part B here. 30 over 2 times our first term, 0.5, plus our last term, 7.75. And then we just type that in the calculator. 30 over 2 times 0.5 plus 7.75. My goodness, the man is running 123 kilometers total. So S sub 30 equals 123.75 kilometers total run. So that says even though he ran 7.75 kilometers on that last day, if you were to add up all the individual ones before it, you get 123.75. And of course, if you don't like this formula, you are welcome to make a chart that goes all the way out 30 times and add up all the individual 30 terms. But you're going to go ahead and get 123.75 of his total run. So there's some special notation sometimes when we have sequences and series. And so sometimes instead of writing out that whole thing, they'll give you something that kind of looks like this. So they have this Greek letter in here. This is the letter sigma. We use this sigma from, by the way, it's from Greek, from Greece, or from the original Greek, whichever you want to have. And we use this as the summation sign, which is no different than what we've been doing so far. So this term here at the bottom is our first term number, and it doesn't always have to be 1. More than likely you'll have 1. Up here at the top we'll have our last term number, and it's not going to be represented with n, it's going to be represented with, like in this case, 3 down here. And this a sub n thing, we've seen this before, this is the equation for individual terms in a sequence. So let's figure out how this thing works. So let's look at this first one. This says our first term, we're starting at 1, so that's our first term number. Our last term number is 3, so we have 3 terms here. Uh-oh, that pen's running out. And we're going to have a grand total of, let's see, it's measured by 2k, so equals, let's see here, so this is our equation. So if we look for the first term, right, instead of using k here, we're going to use 1, so 2 times 1. And then we're going to add that, because this is a summation, which means to add, to the second term values, which is 2 times 2, and we're going to add that to the third term values, which are given by 2 times 3. So that gives us, let's see here, that's going to be 2 plus 4 plus 6, which is going to give us a grand total of, let's see, 2 plus 4 is 6, plus 6 is 12. So that says when we add up all the individual terms in this sequence, we're going to get 12 total for adding up the individual ones. And you don't have to do it exactly like this. If you would like to figure out what each of the individual terms are and then make like a table out of it, you're welcome to. I think this is the most efficient way to do that, though. Is just add up each individual terms and then you are good to go. Okay, all right, folks, let's do some practice on arithmetic series and summation notation.